Good morning, ladies and gentlemen, to all participants, and welcome to International Webinar Program, Zeolite and its Potential Uses in Agriculture. Without further ado, I'll pass the session to our moderator, Dr. Muhammad Haris Ashraf Hassan. Here is some information on our moderator.
Okay, so thank you to Amilisni Perumal as the MC for today. So ladies and gentlemen, welcome to the international webinar, Zeolite and its Potential Uses in Agriculture. So dear participants, as we are about to begin shortly, may I have your attention please? Before we begin, I have a few friendly announcements to be made during the whole program. So I would like all the participants to give your full attention and best interest. Please be reminded to turn on the webcam, and it's optional. Please also disable your speaker during the whole program to avoid any misconducts. Next, should be there any question, please do write down in the chat box so we can tend to your questions or Q&A sessions later. So thank you for your kind cooperation and attention. Yang berbahagia Associate Professor TNC Hasham Dr. Ni Ahmad Nizam Malik, Director of Center for Sustainable Nanomaterials, CS Nano, Universiti Technology Malaysia, and also as the Chairman of Malaysian Zeolite Association. I would like also to welcome all the VIPs, honorable speakers, and all the participants. It is truly an honor to have everyone joining this virtual conference or webinar. Before we proceed to our main agenda, we would like to invite Mr. Muhammad Shamil Wajdi to lead the dua recitation for this morning. Please welcome.
Subhanallah, alhamdulillah, wa la ilaha illallah, wallahu akbar, wa la hawla wa la quwwata illa billahi al-aliyyil azim. Al-Fatihah. A'udzubillahi minasyaitonir rajim. Ar-Rahmanir Rahim. Maliki yawmiddin. Iyyaka nasta'in. Ihdinas siratal mustaqim, siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wa mursalin wa ala alihi wa ashabihi ajma'in. Allahumma ya Rahman, ya Rahim. Segala puji bagi Yang Maha Esa. Selawat dan salam ke atas junjungan kita Nabi Muhammad sallallahu alaihi wasallam dan para sahabatnya, serta bagi mereka yang mengikuti teladan baginda hingga hari kiamat. Allahumma ya Allah, pada pagi yang penuh keberkatan ini, bersempena dengan webinar antarabangsa Zeolit dan potensi kegunaannya dalam pertanian, kami merayu dan berterima kasih kepadamu atas segala nikmat yang tidak terhingga kepada kami, hamba-hambamu yang rendah diri, untuk hidup dalam kehidupan selamat dan sejahtera. Kami memohon restumu untuk melancarkan perjalanan program ini dari awal hingga akhir. Kami memohon bimbinganmu untuk mengelakkan sebarang perkara yang boleh menjejaskan perjalanan program ini. Ya Latif, Ya Mujib, berkatilah kami dengan taufik dan hidayat. Mohon tunjuk ajar kepada warga Universiti Putra Malaysia Kampus Bintulu, MyZA dan institut lain yang terlibat dalam program ini pada hari kebesaran ini. Keamanan dan kesejahteraan di dunia dan di akhirat. Jadikan kami seorang yang intelek, yang bertanggungjawab, Kurniakanlah kami ilmu yang berharga, yang bermanfaat kepada manusia untuk mendapatkan madatillah. Jadikanlah kami hamba-hambamu yang bertakwa, yang menurut perintahmu dan mengabaikan segala perbuatan maksiat. Ampunilah segala kesalahan kami. Ya munzilal barak, kurniakanlah keamanan kepada negara tercinta Malaysia dan negara jiran Brunei dan Indonesia. Lindungilah kami daripada sebarang ancaman dan bencana, baik bencana buatan manusia maupun bencana alam. Dan kepadamu, Ya Allah, kami memohon keselamatan dan kesejahteraan untuk kami, pemimpin kami dan negara kami. Kurniakanlah kesabaran dalam diri kami untuk menghadapi cabaran daripadamu. Terimalah amalan kami dan berikanlah pahala yang setimpal. Rabbana zalamna anfusana wa in lam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa ashabihi wasallam walhamdulillahi rabbil alamin. Amin amin ya rabbal alamin.
Amin ya Rabbal Alamin. Thank you, Mr. Muhammad Shamil Wajdi, for the dual recitation. Ladies and gentlemen, as the curtain opener, I would like to invite Dr. Tengku Sharif as Program Advisor of International Webinar Zeolites and its Potential Uses in Agriculture to deliver her introductory remark. Please welcome.
Thank you very much, Dr. Haris. It's my honor to welcome our honorable guest, Associate Professor Technologist Chemist, Dr. Nik Ahmad Nizam Nik Malik, Director of CS Nano University Technology Malaysia and also a Chairman of Malaysia Zeolite Association. Madam Rosida Binti Basir, Senior Registrar Officer, Kolej Sri Rajang, UPM Bintulu Campus. Mr. Terry Henry, Program Director, International Webinar Zeolite and its Potential Uses in Agriculture. And all to the invitation panel, we have Prof. Dr. Osu today from Universiti Islam Sultan Sharif Ali from Brunei, Associate Professor Chemist Dr. Eng Poh from University Science Malaysia, Penang. And we have Dr. Rino Rahmata Mukti from Institute Technology of Bandung, Indonesia, and also Dr. Latifah Omar from Universiti Putra Malaysia, Bintulu Campus. I would like to express my profound gratitude to all of you today in exploring the program International Webinar Zeolite and its Potential Uses in Agriculture. First of all, I would like to extend my utmost gratitude and appreciation for the opportunity to be involved in this program International Webinar. Congratulations and a job well done to the program committee member for their success in accomplishing this program. I also would like to express my sincere gratitude to all the panel speakers for the contribution on spreading information regarding zeolite and its uses in agriculture. I hope that by the end of this program, all participants will have gained some knowledge about the topic that is so to be discussed later. Finally, I hope that everyone will greatly benefit from this program and be able to apply the knowledge in their bright future. With that, I hope for everyone to fully participate and concentrate in this program for everyone benefit. Thank you very much. Back to you, Dr. Haris.
Thank you very much, Dr. Tengku, for your introductory remark. Next, I would like to invite Yang Berbahagia, Associate Professor, Technologist Chemist Dr. Nik Ahmad Nizam Nik Malik, the Director of Center for Sustainable Nanomaterials, CS Nano, University Technology Malaysia, and also the Chairman of Malaysian Zeolite Association, to deliver his speech and to also officiate our program today. Without further ado, welcome, Doctor.
Okay, can you hear me, Dr. Haris? Okay, alright. Bismillahirrahmanirrahim. Assalamualaikum and good morning, everyone. Thanks to the moderator, Dr. Muhammad Haris. Yang berbahagia, Profesor Dr. Syahrul Raziq Sarbini, Campus Director, Universiti Putra Malaysia, UPM Bintulu Campus. Dr. Kamel bin Abdul Latif, Head of Students Affairs and Alumni and Principal UPM KB. Dr. Tengku Sharifah Mariza binti Tengku Azmi, Program Advisor of this international webinar. Thierry Henry Anak Daniel, Program Director of this international webinar. All of the invited panel speakers, Professor Dr. Osumanu Haruna Ahmed, and Head of Ibnu Sina Laboratory Center and Professor from Universiti Islam Sultan Sharif Ali, Brunei. Associate Professor Chemist Dr. Ng Empoh, Associate Professor at Physical Chemistry Department, University Science Malaysia, USM. Dr. Rino Rahmata Mukti, Assistant Professor at Division of Inorganic and Physical Chemistry, Institute of Technology Bandung, ITB, Indonesia. Dr. Latif Omar, Senior Lecturer at Department of Crop Science, Universiti Putra Malaysia, UPM Bintulu Campus, Sarawak. All of the audience, Alhamdulillah, I am very grateful to Allah Subhanahu Wa Taala today because we have successfully organized this international webinar. Welcome to all of you to the international webinar with the title Zeolite and its potential use in agriculture. So this webinar is organized by Persatuan Zeolit Malaysia or MYZA, Malaysia Zeolite Association, together with a group of students from Kolej Sri Rajang, KSR, UPM Bintulu Campus. MYZA or Malaysia Zeolite Association is actually initiative by the Ibnu Sina Institute for Scientific and Industrial Research, ICC, UTM, together with the Center for Sustainable Nanomaterials, SASNano, UTM. And the MYZA is the organization related to zeolite material, which is one of the natural and synthetic minerals. Actually, we cannot found this zeolite in Malaysia. We can find it in Indonesia and also in other countries. That can be used in agriculture, catalysis industry, and also animal husbandry, as well as in the scientific research. So the main goals of the establishment of the Malaysia Zeolite Association is first, number one is organize studies papers, survey or research on the aspect involved in the field of zeolite. Number two, providing cooperation to the government and its agencies in implementing national policies, especially those involving the field of zeolite. Number three, produce and disseminate information related to the issues in the field of zeolite. So this association was established in October 2021. There will be many programs that related to zeolites in the future that will be organized by MYZA. If you want to become a member, please go to malaysiazeolite.wordpress.com. This is professional association and its membership is open to all Malaysian. Ladies and gentlemen, the main purpose of this international webinar today is to disseminate knowledge about the zeolite. So we need to do this because it is our goal to educate communities about the benefits and use of zeolites in various fields. Maybe one of the speakers can give information about the basic principle of the zeolite. Actually, the zeolite properties is very unique and it can be applied in various fields. I do not want to talk much about the zeolite. I will leave it to the speakers today. Ladies and gentlemen, on behalf of MYZA, I would like to express sincere gratitude and thanks to all of the speakers from different countries. We have speakers from Malaysia, Malaysia, Indonesia, and Brunei. Thanks to all of you. I would also like to thank and congratulate students and advisor, this team from Kolej Sri Rajang KSR, UPM Bintulu Campus, who successfully organized this program, and to all of the committee members involved in this program. We will record this event and we will put this in YouTube for future reference. You can also go to our Facebook and like our page to get information about events and about the zeolites. I hope this event will give knowledge to all of you about the application of zeolites, especially in agriculture, and you all can disseminate this knowledge to others in the future. So with that, I think, thank you very much, everyone. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you, Associate Professor Dr. Ahmed Nizam, for the brief inauguration speech just now. Now we are going to move on to our first slide this morning. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Alhamdulillah, praise to the God because with His grace and blessing we can gather this morning to listen to the briefing about the Clinoptilolite Zeolite and crop productivity and organic and mineral acid soils, which will be presented by our honorable speaker, Professor Dr. Osumanu Harina Ahmed. Before we begin, here is some information about our speakers for today. Professor Dr. Osumanu Harina Ahmed, he is the head of Ibnu Sina Laboratory Center and Professor of Universiti Islam Sultan Sharif Ali, Brunei. Currently, he is an academic and a non-academic board member for several institutions and organizations. He has received approximately 65 academic awards from Malaysia, United States of America, Canada, Germany, Croatia, Romania, Morocco, South Korea, Turkey, and also Indonesia. The contribution of Professor Osumanu to the global scholarship is very profound. This is evident in the fact that he has published approximately 412 scholarly works encompassing 263 refereed journal papers, 19 books, 18 book chapters, 106 papers in conference proceedings, and 11 other scholarly publications. He is also frequently invited as a prominent speaker in several national and also international intellectual forums. Without further ado, with due respects, I invite and welcome Professor Dr. Osumanu Harina Ahmed to deliver his briefing. Please welcome.
Assalamualaikum and good morning, everyone. Please, can you see my slides very well? Before I proceed, may I know whether my slides can be seen?
Yeah. Sure, Prof. We can see your slide.
Okay. Sorry, I'm having a few interference with the slides here. Just a moment. All right. First of all, I would like to thank the organizers, especially the students, for this important meeting. And then I also like to thank Malaysian Zeolite Association and definitely UPM, which has made me what I am today. I'm very grateful to all of you. And thanks a lot for having that kind of confidence in me to present this kind of paper. Well, I'm sorry, I think I have a lot of interferences here. I cannot read my slides very well here. All right. So as you can see, this is a profound statement from the director of FAO. You can see that it says soil is the what? Is the mother of agriculture. And then I said, okay, and definitely is the mother of all agricultural activities. And this is one of the reasons why basically you can see that this year's World Soil Day has been themed as soils, where food begins. So basically what we are going to talk about now is to look at the soil in the context of SDGs. You can see out of the 17 SDGs, you clearly see that 12 of them are on agriculture and 8 of them have been dedicated to soils. So that means that soil is a very important component of agriculture. Now with this prelude, let's go to the subject. We are talking about zeolite and crop productivity vis-a-vis organic and mineral acid soils. Now we have our collaborators. I'm not the only one who did this work, so I'd like to acknowledge those displayed on the screen. Now, My talking point will be hovering around zeolite soil plant interaction. So we'll be looking into agronomic efficiency. We talk about socioeconomic efficiency, and then we also look at environmental efficiency. Now, as we can see, first of all, we need to go back to the soil. And from there, we move to what we call the plant and then zeolite. What will be the role? So the zeolites is the bridge between soil and plant. And then I can say that we have two major types of soils. And these soils are what we call the mineral and organic soils. So I'll be giving example on this as to how we manage them using zeolite. Right. So here, one, when we have soils that are generally formed from minerals or rocks, this will now tend to what we call mineral soils. When you have them from organic materials, they form what we call organic soils. So if we talk about organic soil, what are the materials? We are talking about plants, debris, even human beings, and the like animals. Now, when you have an organic soil, this is how it looks like. It's very familiar, those of you in the Borneo, Malaysia, Brunei, and the like, Indonesia. This is a peat soil at its formative stage, and you can see it's full of woody materials, and that would tell us a lot. So when it undergoes decomposition, when we have a sufficient oxidation, you can see that the woody materials are constantly being degraded, and sometimes they can be formed on a mineral soil. So these are some of the things that we need to understand before we go to zeolite. Now, why am I starting with organic soils? One of the most challenging soils in the world, and you can see that in the Borneo, including Malaysia and the like, peat soil is a very huge, peatland. So at the global scale, what do we see? You can see that the peat is highly distributed across the world. United States, North America, when you say North America, we are talking about United States and Canada. You can see that they dominate a lot, and this is followed by what? Europe. So those of you who know the Scandinavians, if you are talking about Netherlands, Sweden, Finland, and the like, and of course, Asia also is number 3. But when we zoom down to Asia, then we see that almost 20 million hectares of peat soil are found in what? Asia, Southeast Asia. So then you zoom down a little bit, then we can see in Southeast Asia, well, I'm familiar with Malaysia. Of course, Indonesia dominates, but I'm using Malaysia as an example. You can see that 2.5, a million hectares of peats are what you call it available. Now, when you go down to Malaysia, Sarawak will definitely has the largest area, followed by Pahang, and you are talking about Johor and then Selangor. Now, I'm trying to dwell on this because I'm going to show you how you can use zeolite to solve most of the problems on peat soil, vis-a-vis crop growth and development. Naturally, peat soils have problems because they don't have much clay. They are not able to hold nutrients. So when it rains, you can see that you lose most of your nutrients. And some of the nutrients are what we call calcium, magnesium, potassium, and sodium. These are what we call in agriculture base cations. They are alkaline, so they're able to neutralize the soil a bit. But when you lose them, then the soil becomes acidic. This is not the only reason, because also you remember woody materials can be acidic. So naturally, peat soil can also be acidic. But leaching also exacerbate the pH, degree. Of course, we are talking about micronutrient, NPK, and the like. They are also easily leach out. Time will not permit me to go into details on this. And then the micro, one of the key things will be the micro. We are talking about copper, zinc, and boron. These are very, very deficient in the soil. Now, in terms of physical properties, we are talking about poor drainage because they occur in low-lying areas, so they are waterlogged areas. And because they're organic, they don't have the compaction. The compaction is quite low, just like compost. And then you are talking about subsidence, the peat decreases, and then also when you don't drain the peat well, it will dry and it doesn't wet. And you all know that peat can easily catch fire. So these are the things. So you see, when we go to the peat area, because it contains a lot of water, we would like to drain the peat. So if you don't drain it very well and it dries, it's called irreversible drying. So you see something on this area, you can see this is more or less like charcoal. You get what I'm saying? So naturally, this can be, fire can set in and they can destroy the area. That's why we need to understand, how do we use zeolite to avoid some of these things? Right. Of course, the common fire we are all familiar. Now, as you continue to cultivate peat soil, oxidation sets in. So you're going to reduce the depth of the peat soil through oxidation and consolidation. This is what we call subsidence, right? So this becomes more serious when you lose a lot of water. So you see, this was the level of the peat. And then after some years until 2005, you can see you have lost this kind of depth. This kind of thing is not controlled 100%, but you can minimize it, because you cannot really, do away with the microbes that are taking the biological decomposition. This is where peat will set in later. And when the system gets so serious, you can see that initially this was the level of the peat soil, and through subsidence, you can see the coconut trees are being the roots are being displayed out. So these are all going to impinge on negatively on productivity. Of course, when you have the peat soil subsiding, that means that the soil is becoming low level. Therefore, there will be flooding. So these are the on-farm flooding that you can see. This is very, very common. And then sometimes also, whether in Malaysia or Indonesia, whatever, these are very common things, because one of the reasons will be subsiding, assuming your drainage systems are not in place very well. And of course, it doesn't stop there. It can also flood communities. So these are the realities that I'm trying to demonstrate before I go into the subject matter. And infrastructure is not also left out. You can see when you build structures on peat soil, because of the consolidation, the structure will start cracking here and there. And then even roads. So those of you who are familiar, you can see, especially if you look at the coastal road from Bintulu to Miri, you can see that there will be some bumpy areas. So those are the areas that you have the peat soil. So sometimes when it's not well constructed, these are some of the things that you see cracking here and there. So all these things, if we are able to use Zeolite, that should be able to help us. And one thing that is also unique about peat soil will be that we cannot use heavy machinery because of the bearing capacity, they sink. That is why in the oil palm industry, you see that when they do harvesting, they use what they call light bearing capacity, materials. Now, of course, when you come to crops, heavy duty crops like coconut, oil palm, sago, and among others, you can see this is what we call leaning. Now you can see the coconut, the oil palm tree is supposed to stand upright, but you can see because of low bearing capacity, you can see how it leans. So this is going to affect productivity. Of course, there are other methods that I cannot talk about. Time will not permit me. And the last part will be that when they disturb the peat soil, you are going to release a lot of greenhouse gases like carbon dioxide. For example, this is a forest. When you start to drain it, this is a carbon dioxide that you are releasing. Of course, when you did cultivate it for agriculture irresponsibly, then this will be the amount that we are releasing. So all these things, I will be demonstrating how we could use Zeolite to really, really capture some of these things. Today, I'm talking about only the chemical aspect. Okay, so going down to mineral soil is very clear. We all know mineral soils come from rocks and minerals, and then they can be igneous rock, sedimentary rock, and then what we call metamorphic rock. So the type of rock will determine the properties of the soil. You need to understand this before you use the zeolite. And I'm going to demonstrate to you that zeolite works best in organic soils and not very, very much into mineral soils. Of course, we are still researching into these things, so that is very rudimentary. I'm not going to conclude on this. Now, you need to understand the soil color. Example, when the soil is sandy, zeolite works very well because it serves as a glue. Of course, you need to have some organic matter, but you also have to be careful that when you have a sandy soil, you are losing a lot of your nutrients, and therefore you need to see what you can do. And then, of course, when the soil is salty, or it has a lot of lime, how do you work on that? And then calcareous soils are what we call high calcium content of soils. So of course, you are talking about saline soil, or what we call it soils that are salty. And then we are talking about soils that have been reacted with sodium. That is what we call sodification. But what is more important in Malaysia could be the acid soils. And you can see clearly that this kind of soils are acidic because of sometimes iron, aluminium, and the manganese. So you can see clearly the reddish color is telling us that there are some sort of iron. I wouldn't go into details. No, what do we mean by acid soils? These are arable lands in the world, almost 50% of them. But unfortunately, this out of 50, 60% of them are in the tropics and they are acidic. And again, we are going to demonstrate how we could use zeolite to work on them. Now, if you look at Malaysia and the rest of the Borneo, you can see that the entire area is acidic. So this is where, zeolite function very well. Why? Because we'll be able to lock up iron. We also lock up aluminum, and we will also try to suppress manganese, and then we can also suppress sulfur. So once we can do this, then we've already get to the next point of productivity. Now, for iron, I think you are all aware, when you see a soil like this, you can see the reddish coloration is iron, oxidation of iron, like a corrosion. And when you look at the landscape, this one was taken from Bintulu Campus, you can see clearly that this area is full of iron. So you need to work on this. You cannot run away. Now we are working on huge rice growing areas. You can see where I am now, you can see how serious the iron toxicity is. So we are working on this to get them off, but I'll show you some of the prior research that we have done and that has been transferred. So these are the realities. So you can imagine you go in like this without rejuvenating the soil or detoxify the soil, then you go in. Of course, this is what you are going to get. So based on this, what about sulfur? Sulfur, you just look at it, it comes from pyrite and jarosite. So it's a what do you call it? Elemental sulfur, for instance, will undergo oxidation to produce sulfur dioxide, then H2SO4 plus water. So this will make the soil very, very acidic, and this is quite challenging. You can see the coloration. So zeolite is able to do that. Now, manganese is also another problem. And then the last one is what we call aluminium. Aluminium is also a serious one. And if you can look at it, you can see that Malaysia is affected by aluminium also. So you see, aluminium works when your soil pH is, your soil is acidic, and you can see as the soil pH decreases, then aluminium becomes non-toxic. So zeolite is able to do that. Conventionally, we use lime, you see. So when the soil is acidic, you see the roots are not doing very well. But when you use the lime, you are able to reduce the aluminium toxicity, and then the roots are growing, plants roots are growing very well. Here, we're also able to use zeolite because zeolite play a dual role, not only in nutrients and whatever, they are they also fix aluminum and iron, and then they can also neutralize the soil. So these are the things that I think I can share with you for the background. Now let's go to zeolite. Now, like we said, zeolites are very unique kind of materials, and later on you will see how they work very well. And they are just aluminosilicate kind of structure, and you can see how it looks like. So we have two major types. You have natural zeolite, which are formed from volcanic sedimentary rocks, and they are cut across the whole world, being it Africa to Europe. They all cut across. Like Professor Nick said, the president of Zeolite Association in Malaysia, like he said, yes, and you can get this kind of zeolite where you have volcanic eruption. This is why you have it in Indonesia. And then how it forms is just like volcanic ash reacting with alkaline water. Then you form your what we call the zeolite. And then we have almost 67 of them. But Clinoptilolite zeolite has been the most useful one. Even when you go to NASA, when they go to the airspace, that is what they use to capture gases. Mordenite is also used. But what I would like to stress here is zeolite at its natural state is not expensive. For instance, almost 1 million to 1.3 million can be produced yearly. And then definitely it has limitations. Because it's natural, the pore size is not as high as when you have synthetic. And of course, the surface area also is not very high, and it's crystalline. And of course, it has inconsistent nutrients and the like compared to synthetic zeolite. But what I can say is that it has been extensively used, and we have also used it a lot in improving soil physical and chemical. Remember the story that I gave you for peat soil? I was referred to physical and chemical. And of course, they work best in what we call clayey soils, sandy soils, and acidic soils. And it has they have very unique properties. You see, within the zeolite, you have tunnels and you have holes. So on the surface are negatively charged, and in the tunnels also can absorb. So here, zeolite can serve as sorption and desorption. So it takes certain special nutrients. As you can see, is it has very high affinity for potassium and ammonium. And then in terms of what we call it, a selectivity for metallic ions, heavy metals, is going to be lead and cadmium. So that makes it very, very unique. Of course, when we talk about the regulation, it has dual purpose, because now we use zeolite here to capture gases. That is when you are talking about molecular sieving. When they're like less than 3 nanometer, you are able to do that. But when you are talking about charges that are small and big, then we are also talking about cations. And you can see structure very well displayed here. So this is what we are using now. Now for the synthetic zeolite is the opposite. Like I did say, I think it is produced from natural minerals. You are talking about silica, you are talking about clay, feldspar, and the like. And then you react them with like flying ash and the like, then you can undergo thermochemical process. You can talk about ultrasonic and the like. So these are some of the things. I'll leave them for my subsequent, researchers who are well versed in this to talk about. And this has been commercially exploited, like our Honorable President said, that for catalysts, and of course in the nanotechnology industry for pharmaceuticals and then food industry. Now for the non-natural zeolite, of course, is the opposite, because a high capacity, and then it also has high surface area. It also porosity is also high, and definitely it has some sort of ecosystem management issues. But one thing I can say is, because it's synthetic, normally it's relatively expensive because of the cost involved. But in actual fact, it's being used a lot. 1.6 million tons are produced. Now let's go to the practical experience. Now let's see. So in our case, we look at zeolites as enhanced weathering rock. So you see, by nature, zeolite can itself break down, but that is going to be very, very slow. So when you grind it and you increase the surface area, that is what we call enhanced weathering rock. So here we have enhanced the surface area. And how does it work? You see, if you take zeolite, it has some sort of silicon in it. That is what we call calcium silicate. And then we use this to capture carbon dioxide, because carbon dioxide dissolve in water, become carbonic acid. And then the calcium in the calcium silicate of the what we call it zeolite will now react with what we call the carbon dioxide. So I'm going to show you how we use it to reduce carbon dioxide and then nitrous oxide. So those of you who are interested in the chemistry, these are the details. You might get my slides. And remember, I did tell you about the leaching of nutrients. So we also use it to capture nutrients, especially in peat soil, because it serves as a sticky material to hold the nutrients. So this is how it is. So we've done all the characterization, and let me run you through some of the work that we have done so far. Of course, when you talk about nitrogen, I will leave it to Dr. Latifa, but we are very, very clear that it's been able to absorb a lot of ammonium to reduce it from, to prevent it from microbial attack and to release it slowly in terms of nitrate. And phosphorus, zeolite is not very significant, effective in capturing what we call it phosphorus. But what it does is it's able to reduce aluminum and iron so that it will release phosphorus for the plants to be taken. But it also somehow absorbs through what we call absorption, but not like cations. So in a way, it's able to buffer pH and reduce iron and aluminum toxicity. And this is the concept. You can see clearly the tunnels and then the charges. So when you apply your fertilizer, what you see is they go into the tunnels and the charges through absorption and desorption. And then from here, this is how it is. So you see, because they are highly negatively charged, they can hook onto iron, aluminum, and the like, and then repel phosphorus in particular, so that plants can take them to grow and develop. So these are some of the things. Potassium, definitely the high affinity of what we call zeolite works a lot. So that is how it is. Now, we're also interested in zeolite because we did some work and we saw that when you use zeolite, because of the silica content, it's able to really resist pest and disease attack, because it builds the cell integrity of the plants. So in fact, you see in rice that the stem, the rice plants will be able to stand upright, and then what we call the greens do not drop. So these are some of the things that I think zeolite can do. Now, let me share you one of the examples that we did, papaya on peat soil. So we try to look at the amount of zeolite that we use, very little per plant, 50 grams until 125 grams. So you see, I mean 12.5 grams. So we compare with the chemical fertilizers and then the like. So this is how we apply the zeolite. And we really were able to have some profound results. You can see, you don't see leaning. You can see that the papaya plants are growing very upright. You don't see leaning and whatever. This is because of the silica. At the same time, they are building the soil physical properties. Now, let me share with you some of the findings. We were able to double the yield of papaya, and as you can see on my screen, and you know papaya, the quality in terms of the taste is very good, is very important, and we'll also improve that. And of course, in terms of nutrient uptake, NPK and the like, we have also been able to do that. We just have one of our papers published last week. If you want to read it, you can go to my Google Scholar. A number of work on that. Of course, pH also improved. And one striking thing is that we are able to reduce the harvest period from 8 months to 6 months, and the fruit weight has been increased to 2.2 to 2.6 kg. And this is vividly clear. You can see how T5 is when you use chemical fertilizer. T1, T2, T3, T4, T5 is when you use zeolite at the different levels. And you can see clearly that we are able to increase the pH compared with what I mean there when you don't use the zeolite. And those of you who are interested, we look at the papaya phases. We are talking about flowering, fruiting and harvesting. And all these properties are far better than T5, which is the chemical. So these are the realities that we found for papaya on peat soil. So you can see whether nitrogen and the like, they all work very well. So these are some, if you want the details, these are the details that you can find in our papers for you to have all the agronomic properties, the sweetness and the diameter, all of them can be found. And when we did the cost benefit analysis, we can see that really we are able to almost double the what we call it the income of the farmers around this kind of project. And like I did say, we also use, the same zeolite during the research and the work also. We were able to use it to capture what we call a carbon dioxide vis-a-vis chemical fertilization, as you can see. And very interesting is also nitrous oxide. I will not be able to go into too much of the chemistry because of lack of time. So for pineapple, we have also demonstrated that on peat soil. And as you can see here, you can see also we found a similar thing like NPK improve. You are talking about here we didn't do liming, so we are able to save liming. Can you imagine on peat soil you say no liming, but when you use this zeolite very well, then that is how it works. And also the fruit weight, and then the per plot, what are we getting, and then the taste, most of these have been improved. And then this, if you translate them into dollar and cent, this is what we are getting. And of course, we also determine the gases. And then again, we could see that we can clearly see that the zeolite can reduce the carbon dioxide and then nitrous oxide emission. And these all were built, are on peat soil. And again, if you need more information, you can read from our papers and the like, or the books. So these are the things. Now for paddy, now I've moved you from organic soils. I'm now moving you to mineral soils. So one of them is paddy. That is what we are working on. We have done some basic work where we try to compare when you use, example, chemical fertilizer, and then you use, let's say, like organic system, like you use biochar or use compost and zeolite. So we did this study for almost 3 cropping cycles. And then these are some of the things that I can show you. This is when you have the soil alone. This is when you have the chemical fertilizer. This is compost, and this is what we call the biochar. Then this is a zeolite. One thing about this organic and mineral, conditioners, they should be able to neutralize your soil and detoxify or condition the soil. So you can see when you use the chemical fertilizer, the color of the soil looks like yellow. That tells you that you have not conditioned the soil. And you can see when we use both organic and inorganic, this is zeolite, you can see the color is almost what? Grayish. So this is what we talk about when we say you use the conditioners. So that is what we call detoxification. So aluminum, iron, and the like are all being detoxified and then chelated. So these are some of the plots you can see. Those that you can see growing within 30 days are the ones with organic and inorganic. For instance, when you take this is zeolite. When you take this is a biochar, this is compost. So you can see the organic systems are working better than when you use zeolite on the mineral soil for rice only, because Dr. Latifa found in a different way when you use maize, it's a different issue. But I'm talking about rice. So this is what we found. So we monitor all again and again, and then this is how it is. You can see this is when you use zeolite, and this is when you use biochar, when you use compost, and this is chemical. You can see they stand upright. But in terms of productivity, the organic system is better. Remember, because zeolite is a mineral, it works very well in organic, and the opposite is true for the mineral. But again, this is not very conclusive because we are putting other students to work on this for another period of time so that we can have some conclusive findings. So these are the things that I can share with you. And these are the yield information that you can see. The organic system look far better than when you talk about the zeolite. But again, they look a little relatively better than the chemical. In terms of ammonia loss, you know, when you use nitrogen, you have a lot of ammonia coming out. That is something very interesting. Zeolite perform as the best medium of capturing ammonia. And we are not surprised because it's able to capture a lot of ammonium, not ammonia, because it stops it from what you call ammonia volatilization. So these are some of the details that I can share with you. Time will not permit me to go through. But again, if you need these slides, I will be able to send them to you, and then for your own benefit. Now, for me to summarize, because I'm being given the time to stop in the next few minutes, what I can say is that the way forward here is, one, we are very, very sure, and it's very conclusive that zeolites works very well on peat soils. And in fact, we are conducting another work that is on oil palm, and we are having very, very good results. I cannot share with you at this moment because of confidentiality. These are the things that I can say. And in terms of carbon capture, zeolite is very good when we use them on peat soils. However, it appears that it's less effective on mineral acid soils for paddy, please. Based on what we have found, I'm not extending it to other crops, but it's not conclusive because we are trying to consolidate with more work. And then, of course, that is another aspect that I think we are looking into. Is more effective as well, but in terms of ammonia, we have been able to demonstrate that. Now, for me to get winding down my talk, what I can say is, if you really, really would like to improve or have a sustainable soil management in your farms, you can go organic, that is fine. But remember, zeolite is also a mineral, and it is not chemical. It's a natural kind of thing, which is a mineral. So if you are able to use it, you could be able to guarantee your soil health, and then it will cascade or translate into healthy crop growth. Of course, it might also, like animal husbandry, is also good for healthy food, and it should translate into healthy society. Ladies and gentlemen, thank you very much for your kind attention. And then I would like to thank you for your audience. And then again, my special thank you to Professor Nick Ahmed Nizam. He's been a collaborator for many years when I was in Malaysia. And I would like to thank all the members of UPM Bintulu Campus and all our co-researchers and our dear students. Special greetings. Assalamu alaikum, and thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. And also thank you to Professor Dr. Osumanu Harina for your very comprehensive sharing about zeolite, and also about the interaction on zeolite and its use in the soil. So with this, we have finished on our first slot, and I hope all participants can comprehend